Hey everybody, John back. In the last video we talked about how adding and subtracting inside and outside the function affects the original graph. So we're going to go through and we're going to combine two things happening at once. We are adding 2 inside the function. We are subtracting 3 outside the function. And I can tell which one is inside and which one's outside because the function itself is the square root of x. And the square root ends here. So the plus 2 is inside the square root, so that's inside the function. And the minus 3 is outside the square root, which makes it outside the function. So before we get to graphing, I want to talk about how we would describe what's actually happening to g of x. So if f of x is my parent function, which is the square root of x, compared to f of x, what is g of x going to look like? Well, I think the shape is going to be exactly the same. The difference is g of x is f of x, except it has been shifted 2 units, and hopefully you know which direction this is going. I'm shifted 2 units, f of x is shifted 2 units to the left. And 3 units down. Okay, so g of x is f of x. It's going to be exactly the same shape, except it's going to start, well, every point on the graph is actually going to be shifted 2 units to the left and 3 units down. Okay, so let's go ahead and graph this now that we have an idea of what it's going to look like. Okay, so I have my graph paper here. I'm going to go ahead and set up a coordinate plane. Okay. We've got our x-axis, we've got our y-axis. Okay, we've got a scale, so in both directions each box represents 1 unit. Now let's just take another look at the function. G of x is the square root of x plus 2 minus 3. So g of x is the square root of x plus 2 minus 3. And if it helps you, I like to put a little, roof on this thing. I like to show where the roof is ending on the square root so that it makes it very clear what's inside the square root and what's outside the square root. So before we actually graph g of x, I'm going to graph f of x. Now, f of x is my parent function. It's my most basic square root function, the square root of x. And I want to go through what the pattern is for the square root of x. The pattern for the square root of x is the same pattern as x squared, just instead of the up changing from 1, 3, 5, 7, 9, it's the to the right that changes. The up stays 1 each time, just like with x squared, it was the out it was out 1, out 1, out 1, and it was the up that went 1, 3, 5, 7, 9. Here, what's happening is, if we think about it, if I want a perfect square, like 0 is a perfect square, so if I plug 0 in, I get 0 out. 1 is also a perfect square, I get 1, I put 1 in, I get 1 out. And so if I plug in 0, I'll get an even number out, I get 0 out. If I plug 1 in, I get 1 out. If I plug the next even number to plug in, perfect square to plug in, would be 4, and I would get 2 out. So these are my x's, these are my y's, and then 9 would be the next number, so I'd get 3 out. So notice how this is 1, 3. My x's are 1, 3, 5, and then the next one would be 7, but my output, my y's, are going up 1, 1, 1, 1. So what does this graph look like? Well, it starts at 0, 0. That's my starting point. And from there, I go up 1 to the right 1. Up 1 to the right 3. Up 1 to the right 5. Up 1 to the right 1, 2, 3, 4, 5, 6, 7. And that's as much as can fit on this graph. Between 0 and 1, there's a nice curve here because the square root of 1/2 is actually, well, let's do the square root of 1/4. The square root of 1/4 is 1/2. And so if I plug in a number like a quarter, I actually get a number that's bigger than that. So a 1/4 would be down here, but when I plug in a quarter, I actually get a half out. So this actually curves up like this. I'm getting bigger values than I would because I'm square rooting, and then it sort of starts to curve out this way. So this is my parent function right here, and I probably should have done it in let's do it in like highlighter so that it's a little bit lighter here. So there's my parent function. I don't know that that's better. Yeah. Let's stick with the pencil. Okay. So there's my parent function. So the difference between f of x and g of x is just the starting point. The pattern, this pattern here is going to look exactly the same. And so I'm going to graph g of x, which starts, compared to f of x, it starts 2 to the left and 3 down. So I go 2 to the left and 3 down. So there's my starting point. And now from here I count the same pattern. Up 1 to the right 1. Up 1 to the right 3. Up 1 to the right 5. Up 1 to the right 1, 2, 3, 4, 5, 6, 7. And I can't fit any more on there. And so the shape of the graph is exactly the same. It's just shifted 3 units to the left and 2 units to the left and 3 units down. And that's true for every point. Notice here, if I go 2 to the left and 3 down, I get another point. I get a point on the other graph. And so every single point on the graph of g of x is a point on f of x that's been shifted 2 to the left and 3 down. All right. So I will see you in the next video when we talk about reflections.